Just 4.24 light-years away, a world unlike any other in our solar system orbits the star Proxima Centauri. This isn't just any world, it's Proxima Centauri b, our nearest potentially habitable neighbor. Imagine a planet where the sun doesn't rise and set, but a single star, Proxima Centauri, hangs in the sky, casting an eternal twilight. Discovered in 2016 through the subtle wobbles it induces in its parent star, this exoplanet has sparked a frenzy of excitement and speculation. Could this be our next home? Join us as we dive into the captivating story of Proxima Centauri b, exploring its discovery, its potential to host life, and the challenges and triumphs of studying a world so tantalizingly close, yet so far away. The Proxima Centauri system. Nestled in the constellation of Centaurus, about 4.24 light-years from our solar system, lies the Proxima Centauri system. At its heart is Proxima Centauri, a small, faint red dwarf star. It's the closest star to our Sun, and it has a companion planet that has sparked considerable excitement in the astronomical community. This planet, Proxima Centauri b, orbits within the habitable zone of its star, where conditions might be just right for liquid water to exist. The proximity of this system to us makes it a prime target for future exploration and study. The discovery of Proxima Centauri b was announced in 2016, the result of years of painstaking observation and analysis. Astronomers used the radial velocity method, detecting the tiny wobbles in Proxima Centauri's motion caused by the gravitational pull of the orbiting planet. These wobbles are minuscule, but sophisticated instruments like the HARP spectrograph at the European Southern Observatory's La Silla facility in Chile can pick them up. The planet is roughly Earth-sized, and its orbit takes it around its star every 11.2 Earth days. Despite its close proximity to Proxima Centauri, the star's dimness means the planet might receive similar amounts of energy as we do from the Sun. Proxima Centauri b's potential habitability is a hot topic. The planet's proximity to its star raises questions about tidal locking, where one side of the planet perpetually faces the star, potentially leading to extreme temperature differences. However, if the planet has a substantial atmosphere, it could redistribute heat and moderate temperatures. Additionally, red dwarfs like Proxima Centauri are known for their stellar flares, which could strip away a planet's atmosphere and bombard it with radiation. Yet, Proxima Centauri b's proximity and location within the habitable zone make it a compelling candidate for further study. Future telescopes, like the James Webb Space Telescope, may provide more insights into this enigmatic world. Discovery of Proxima Centauri b. In the vast, cold expanse of space, a mere 4.24 light-years from our solar system, a tantalizing world orbits a star named Proxima Centauri. This star, the closest to our Sun, hosts a planet that has ignited the imagination of scientists and dreamers alike, Proxima Centauri b. Its proximity and potential habitability make it a prime target in the search for life beyond Earth. The discovery of this exoplanet was a monumental moment, marking a significant step in our quest to understand our place in the universe. The journey to find Proxima Centauri b was a testament to human ingenuity and perseverance. Astronomers employed the radial velocity method, a technique that detects the tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. These wobbles are subtle, often no more than a gentle whisper in the cosmic noise. Yet, using the European Southern Observatory's HARP spectrograph, scientists managed to discern this whisper. The data revealed a planet with a minimum mass of about 1.3 times that of Earth, orbiting within the habitable zone of Proxima Centauri. This zone, often referred to as the Goldilocks zone, is where temperatures could allow for liquid water to exist on the surface. The news of Proxima Centauri b's discovery sent ripples through the scientific community and beyond. Here was a planet that could, potentially, harbor life. Its proximity to us means that it is a prime candidate for further study, including the search for biosignatures in its atmosphere. The James Webb Space Telescope, set to launch soon, could provide valuable insights into this enigmatic world. Moreover, initiatives like Breakthrough Starshot aim to send tiny probes to the Alpha Centauri system, of which Proxima Centauri is a part, within our lifetimes. The dream of interstellar travel, once the stuff of science fiction, is now being seriously discussed. Yet, the story of Proxima Centauri b is not without its challenges. The planet orbits a red dwarf star, a type known for intense stellar activity. Flares and radiation could strip away a planet's atmosphere and bombard its surface with harmful particles. Whether Proxima Centauri b has managed to retain an atmosphere, or if it has the right conditions for life to thrive, remains unknown. But the mere possibility is enough to fuel our curiosity and drive our exploration. In the grand tapestry of the cosmos, Proxima Centauri b is a thread that connects us to the broader narrative of life in the universe. And as we continue to unravel this narrative, we edge ever closer to answering one of humanity's most profound questions: are we alone? Proxima Centauri b. Basic characteristics. Nestled in the constellation of Centaurus, a mere 4.24 light-years from our solar system, lies Proxima Centauri b, an exoplanet that has captured the imagination of astronomers and dreamers alike. This distant world orbits within the habitable zone of its parent star, Proxima Centauri, a red dwarf that is the closest star to our Sun. The term habitable zone might evoke images of lush landscapes and flowing rivers, but it simply means the region around a star where the temperature could allow for liquid water to exist on a planet's surface. Proxima Centauri b's proximity to us makes it a prime target for future exploration and study. The discovery of Proxima Centauri b was announced in 2016, the result of years of painstaking observation and analysis. Astronomers used the radial velocity method, detecting the tiny wobbles in Proxima Centauri's motion caused by the gravitational pull of the orbiting planet. These wobbles are minuscule, akin to the gentle sway of a tree branch in a light breeze, but modern instruments are sensitive enough to pick up these subtle signals. The planet's mass is at least 1.17 times that of Earth, and it completes an orbit around its star every 11.2 Earth days. This close orbit might seem extreme, but Proxima Centauri is much cooler and dimmer than our Sun, so the planet receives a similar amount of energy as Earth does from the Sun. Despite its promising location, Proxima Centauri b faces significant challenges that could hinder its habitability. The planet is likely tidally locked, meaning one side perpetually faces its star while the other remains in eternal darkness. This could create extreme temperature differences and violent winds. Additionally, Proxima Centauri is known for powerful stellar flares that could strip away any potential atmosphere and bombard the surface with harmful radiation. However, there's still much to learn. Future telescopes, like the James Webb Space Telescope, may provide more insights into the planet's atmosphere and surface conditions. For now, Proxima Centauri b remains a tantalizing enigma, a nearby world that could be a stepping stone to understanding our place in the cosmos. The habitable zone concept. Nestled in the constellation of Centaurus, a mere 4.24 light-years from our solar system, lies Proxima Centauri b, an exoplanet that has captured the imagination of astronomers and dreamers alike. This distant world orbits within the habitable zone of its star, Proxima Centauri, a red dwarf that is the closest stellar neighbor to our Sun. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where the temperature is just right for liquid water to exist on the surface of a planet. This is a crucial factor in the search for life beyond Earth, as water is a key ingredient for life as we know it. The discovery of Proxima Centauri b was announced in 2016, the result of years of painstaking observation and analysis by astronomers using the radial velocity method. This technique involves detecting the tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. The wobbles of Proxima Centauri revealed the presence of a planet with a minimum mass of about 1.3 times that of Earth, orbiting its star every 11.2 days. The proximity of Proxima Centauri b to its star is much closer than Earth is to the Sun, but because Proxima Centauri is a cool red dwarf, the planet still lies within the habitable zone. However, the habitable zone concept is not as straightforward as it might seem. While Proxima Centauri b receives about 65% of the sunlight that Earth does, it is also subject to intense stellar activity, including powerful flares and radiation. This could potentially strip away the planet's atmosphere and expose any surface life to harsh conditions. Additionally, the planet is likely tidally locked, meaning one side permanently faces its star while the other is in perpetual darkness. This could create extreme temperature differences and atmospheric circulation patterns that might make habitability challenging. Despite these challenges, the potential habitability of Proxima Centauri b makes it a prime target for further study. Future missions, such as the James Webb Space Telescope, aim to analyze the planet's atmosphere and search for biosignatures, such as oxygen and methane, which could indicate the presence of life. The proximity of Proxima Centauri b also makes it a tantalizing target for future interstellar probes, such as Breakthrough Starshot, which aims to send tiny spacecraft to the Alpha Centauri system at a fraction of the speed of light. While many questions remain about the true nature of this distant world, one thing is clear. Proxima Centauri b represents a tantalizing step in our ongoing quest to understand our place in the cosmos. Proxima Centauri b's location in the habitable zone. Nestled in the constellation of Centaurus, a mere 4.24 light-years from our solar system, lies Proxima Centauri b, an exoplanet that has captured the imagination of astronomers and space enthusiasts alike. This distant world orbits within the habitable zone of its parent star, Proxima Centauri, a red dwarf that is the closest star to our Sun. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where the temperature is just right for liquid water to exist on the surface of a planet. Proxima Centauri b's location here has sparked considerable excitement, as water is a key ingredient for life as we know it. The discovery of Proxima Centauri b was announced in 2016, the result of years of painstaking observation and analysis by the Pale Red Dot campaign. This international collaboration of astronomers used the High-Accuracy Radial Velocity Planet Searcher, HARPS, at the European Southern Observatory's La Silla facility in Chile. They detected the planet by observing the tiny wobbles it induces in its parent star's motion due to its gravitational pull. These wobbles, though minuscule, were enough to reveal the presence of a planet with a minimum mass of about 1.3 times that of Earth, orbiting its star every 11.2 days. Such a close orbit might seem inhospitable, but Proxima Centauri is much cooler and dimmer than our Sun, making this orbit the equivalent of a temperate, life-friendly zone. Despite its promising location, Proxima Centauri b faces significant challenges to habitability. The planet is subject to intense stellar radiation and frequent flares from its active parent star. These flares could strip away the planet's atmosphere and expose its surface to harmful radiation. Additionally, the planet is likely tidally locked, meaning one side perpetually faces the star while the other remains in eternal darkness. This could lead to extreme temperature differences and harsh conditions. However, recent studies suggest that if Proxima Centauri b has a thick atmosphere or a strong magnetic field, it might be able to retain liquid water and support life. The possibility of habitability, however slim, keeps scientists intrigued and motivated to learn more about this enigmatic world. The proximity of Proxima Centauri b makes it an ideal target for future exploration and study. Its relative closeness allows astronomers to gather more detailed data than they can for more distant exoplanets. Advanced telescopes, such as the James Webb Space Telescope, may one day be able to analyze the planet's atmosphere, searching for biosignatures like oxygen, methane, and water vapor. Moreover, ambitious projects like Breakthrough Starshot aim to send tiny, lightweight probes to the Alpha Centauri system, which includes Proxima Centauri, within the next few decades. These probes could provide unprecedented close-up images and data about Proxima Centauri b, potentially revealing whether this nearby world is truly habitable. The journey to understand Proxima Centauri b is just beginning, and with each new discovery, our nearest potentially habitable neighbor continues to captivate and inspire. Planetary conditions, temperature. Nestled in the habitable zone of our nearest stellar neighbor, Proxima Centauri, lies a planet that has captivated astronomers and dreamers alike. Proxima Centauri b, often hailed as our closest potentially habitable neighbor, orbits a red dwarf star just 4.24 light-years from Earth. This proximity makes it a tantalizing target for exploration and study. The planet's temperature is a critical factor in determining its potential habitability. Estimates suggest that Proxima Centauri b receives about 65% of the stellar flux that Earth receives from the Sun. This places it within the range where liquid water could exist on its surface, a key ingredient for life as we know it. However, the temperature on Proxima Centauri b is far from uniform. The planet is likely tidally locked to its star, meaning one side perpetually faces Proxima Centauri while the other remains in eternal darkness. This creates a stark contrast between the scorching, sunlit side and the frigid, shadowed side. The temperature on the day side could soar to boiling points, while the night side might plunge to freezing cold. The terminator, the line dividing day and night, could be the most hospitable region, with temperatures potentially suitable for liquid water. This complex thermal environment raises intriguing questions about the planet's climate and atmospheric dynamics. The discovery of Proxima Centauri b was a monumental achievement, announced in 2016 based on data from the European Southern Observatory's Pale Red Dot campaign. Astronomers detected the planet using the radial velocity method, observing the subtle wobbles in Proxima Centauri's motion caused by the gravitational tug of the orbiting planet. This method provided crucial insights into the planet's mass and orbit, but the temperature remained a subject of speculation and modeling. Subsequent studies have refined our understanding, incorporating factors like atmospheric composition and stellar radiation. The planet's temperature is now believed to be within a range that could allow for liquid water, but the exact conditions remain uncertain. Understanding the temperature of Proxima Centauri b is not just an academic exercise. It has profound implications for the search for extraterrestrial life. If the planet has an atmosphere that can redistribute heat and moderate temperatures, it might support liquid water and, potentially, life. The study of Proxima Centauri b's temperature also sheds light on the broader question of habitability around red dwarf stars, the most common type of star in our galaxy. As we continue to explore this enigmatic world, we edge closer to answering one of humanity's oldest questions: are we alone in the universe? Planetary conditions, radiation. Nestled in the Alpha Centauri star system, a mere 4.24 light-years from Earth, lies Proxima Centauri b, our nearest potentially habitable neighbor. This exoplanet orbits within the habitable zone of its red dwarf star, Proxima Centauri, where temperatures could allow for liquid water to exist. However, the journey to understanding its potential habitability is fraught with challenges, not least of which is the intense radiation it faces. Proxima Centauri b is subjected to significant radiation due to its close proximity to its host star. Red dwarfs like Proxima Centauri are known for their stellar flares, which are sudden and intense bursts of energy. These flares can bathe the planet in high levels of 10th rays and ultraviolet radiation. Studies have shown that Proxima Centauri experiences such flares relatively frequently, which could have profound implications for any potential atmosphere and surface conditions on Proxima Centauri b. The radiation could strip away atmospheric gases, making it difficult for the planet to retain an environment conducive to life as we know it. The discovery of Proxima Centauri b was a monumental achievement, announced in 2016 by the European Southern Observatory. Astronomers detected the planet using the radial velocity method, observing the slight wobbles in the star's motion caused by the gravitational pull of the orbiting planet. This method, combined with extensive follow-up observations, confirmed the presence of Proxima Centauri b. The planet's orbit is remarkably close to its star, completing a full revolution in just over 11 Earth days. This proximity is a double-edged sword. It places the planet within the habitable zone, but it also exposes it to the star's intense radiation and gravitational forces. Despite the harsh radiation conditions, the potential for habitability remains an intriguing possibility. Scientists speculate that Proxima Centauri b might have a tidally locked orbit, meaning one side of the planet perpetually faces the star while the other remains in darkness. This could create a stark contrast between the scorching, irradiated side and the frigid, dark side. However, the terminator line, the boundary between the two sides, could harbor a more temperate environment where liquid water might exist. Additionally, the planet's atmosphere, if it has one, could play a crucial role in mitigating the effects of radiation and redistributing heat. Understanding these dynamics is key to assessing the planet's habitability and the potential for life to emerge or be sustained. Planetary conditions, tidal locking. Nestled in the constellation of Centaurus, a mere 4.24 light-years from our solar system, Proxima Centauri b orbits its red dwarf star, Proxima Centauri. This exoplanet, our closest potentially habitable neighbor, has sparked immense interest due to its proximity and the tantalizing possibility of harboring conditions suitable for life. Discovered using the radial velocity method, which detects the wobble of a star caused by an orbiting planet, Proxima Centauri b is about 1.3 times the mass of Earth. Its orbit lies within the habitable zone, where temperatures could allow for liquid water to exist. However, one of the most intriguing and challenging aspects of Proxima Centauri b is its likely tidal locking. Tidal locking occurs when an orbiting body always presents the same face to its parent star, much like the Moon does with Earth. This phenomenon is probable for Proxima Centauri b due to its close proximity to its star and the gravitational forces at play. On the tidally locked side of Proxima Centauri b, temperatures could soar, making it inhospitable. The opposite side, perpetually in darkness, would be freezing cold. The thin sliver of twilight that separates these two extremes might be the only region where liquid water, and potentially life, could exist. This stark contrast in temperatures and conditions presents a significant challenge for habitability. Despite these challenges, the potential for habitability on Proxima Centauri b cannot be dismissed outright. The planet's atmosphere, if it exists, could play a crucial role in moderating temperatures and redistributing heat. A thick atmosphere might help to transfer heat from the day side to the night side, creating more temperate conditions. Additionally, the presence of an atmosphere could protect the planet from harmful stellar radiation. Proxima Centauri is a red dwarf star, known for its intense flares and high levels of radiation. These factors could strip away an atmosphere over time, but if Proxima Centauri b has a magnetic field, it might be able to shield itself to some extent. Understanding the conditions on Proxima Centauri b is a complex puzzle that scientists are still piecing together. The planet's tidal locking presents both obstacles and opportunities for habitability. While the extremes of temperature and radiation pose significant challenges, the potential for a temperate twilight zone and the protective role of an atmosphere offer hope. As our closest potentially habitable neighbor, Proxima Centauri b continues to captivate our imagination and drive our quest to explore the possibilities of life beyond Earth. Future missions and advancements in technology will be crucial in unraveling the mysteries of this enigmatic world. Atmospheric considerations. Nestled in the habitable zone of Proxima Centauri, a mere 4.24 light-years from our solar system, Proxima Centauri b is the closest exoplanet that could potentially harbor life. This tantalizing proximity makes it a prime target for astronomers seeking to understand the atmospheric conditions that might support life beyond Earth. The discovery of Proxima Centauri b was a monumental achievement, announced after careful analysis of radial velocity data from the European Southern Observatory's HARP spectrograph. This method detects the tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. The planet's presence was inferred from these subtle shifts, marking a significant milestone in the search for Earth-like worlds. The atmosphere of Proxima Centauri b is a subject of intense speculation and study. Given its close orbit around a red dwarf star, the planet is likely tidally locked, meaning one side perpetually faces the star while the other remains in eternal darkness. This extreme contrast could lead to dramatic atmospheric dynamics. On the sunlit side, temperatures might be high enough to vaporize water, while the dark side could be cold enough to freeze it. The terminator, the line between day and night, might be the most hospitable region, with temperatures suitable for liquid water. However, the star's intense stellar winds and frequent flares pose significant challenges. These energetic events could strip away the planet's atmosphere over time, making it difficult for life as we know it to thrive. Scientists are using advanced models and observations to probe the atmospheric composition of Proxima Centauri b. The James Webb Space Telescope, JWST, and future instruments like the Extremely Large Telescope, ELT, will play crucial roles in this endeavor. By analyzing the starlight filtering through the planet's atmosphere during transits, researchers hope to detect biomarkers such as oxygen, methane, and water vapor. These molecules could indicate the presence of life or, at the very least, conditions conducive to it. The search for these atmospheric signatures is ongoing, with each new observation bringing us closer to understanding whether Proxima Centauri b could be a second home for life in the cosmos. The potential habitability of Proxima Centauri b hinges on a delicate balance of atmospheric factors. One critical consideration is the planet's ability to retain a stable atmosphere. The star's intense radiation and solar winds could erode the atmosphere over time, but the planet's magnetic field might offer some protection. If Proxima Centauri b has a strong magnetic field, it could shield its atmosphere from these harsh conditions, increasing the chances of habitability. Additionally, the presence of a thick atmosphere could help regulate temperatures, preventing extreme variations between the day and night sides. This atmospheric regulation is crucial for maintaining liquid water, a key ingredient for life as we know it. The interplay of these factors makes Proxima Centauri b a fascinating subject for further study and exploration. Potential for liquid water. Nestled in the habitable zone of Proxima Centauri, a mere 4.24 light-years from our solar system, lies Proxima Centauri b, a planet that has ignited the imagination of astronomers and space enthusiasts alike. This exoplanet, often hailed as our nearest potentially habitable neighbor, orbits within the temperate region of its star, where conditions might allow for liquid water to exist. The proximity of Proxima Centauri b makes it a prime target for future exploration, offering a tantalizing opportunity to study a world that could harbor conditions similar to those found on Earth. The discovery of Proxima Centauri b was announced in 2016, the result of a meticulous campaign using the radial velocity method. Astronomers detected the subtle wobbles in the motion of Proxima Centauri caused by the gravitational pull of the orbiting planet. These observations revealed a planet with a minimum mass of about 1.3 times that of Earth, completing an orbit around its star every 11.2 Earth days. The star itself, a red dwarf, is much cooler and dimmer than our Sun, but Proxima Centauri b's close orbit places it in a region where liquid water could theoretically exist on its surface. One of the most compelling aspects of Proxima Centauri b is its potential to host liquid water, a crucial ingredient for life as we know it. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where the temperature is just right for water to remain in its liquid state. Proxima Centauri b's orbit falls within this zone, but the planet's habitability is influenced by a myriad of factors. The star's intense stellar activity, including frequent flares, could strip away the planet's atmosphere and expose it to harmful radiation. Additionally, the planet's proximity to its star means it is likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. This could lead to extreme temperature differences and atmospheric dynamics that might not be conducive to life. Despite these challenges, the possibility of liquid water on Proxima Centauri b remains a tantalizing prospect. Recent studies have suggested that the planet might have a substantial atmosphere, potentially capable of redistributing heat and protecting the surface from stellar radiation. Moreover, the presence of water could be maintained through subsurface oceans, shielded from the harsh conditions on the surface. Future missions, such as the James Webb Space Telescope and advanced ground-based observatories, aim to probe the planet's atmosphere and surface conditions, providing valuable insights into its potential habitability. As our understanding of Proxima Centauri b deepens, so too does our fascination with this enigmatic world, a beacon of hope in our quest to find life beyond Earth. Comparative planetary habitability. Nestled in the habitable zone of Proxima Centauri, a red dwarf star just 4.24 light-years from our Sun, lies Proxima Centauri b. This exoplanet, often hailed as our nearest potentially habitable neighbor, has sparked considerable excitement and speculation. Its proximity alone makes it a prime target for study, offering a tantalizing opportunity to explore worlds beyond our solar system. The discovery of Proxima Centauri b was announced in 2016, the result of a meticulous analysis of radial velocity data from the European Southern Observatory's HARP spectrograph. This method detects the subtle wobbles in a star's motion caused by the gravitational pull of an orbiting planet. The planet's presence was inferred from these tiny fluctuations, a testament to the precision of modern astronomical instruments. Comparative planetary habitability is a fascinating lens through which to view Proxima Centauri b. In our solar system, Earth stands as the gold standard for habitability, with its abundant liquid water, stable climate, and protective magnetic field. Mars, with its thin atmosphere and harsh conditions, offers a stark contrast. Proxima Centauri b, however, presents a different scenario altogether. Orbiting a red dwarf star, it receives significantly less light and heat than Earth does from the Sun. This raises intriguing questions about what habitability might look like on such a world. The planet's proximity to its star means it likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. This could create extreme temperature gradients and unique environmental conditions. Despite these challenges, Proxima Centauri b's location within the habitable zone suggests that liquid water could exist on its surface. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where temperatures are just right for liquid water to persist. However, the planet's potential habitability is far from certain. Red dwarf stars are known for their intense stellar activity, including powerful flares and strong stellar winds. These factors could strip away a planet's atmosphere and expose its surface to harmful radiation. Additionally, the planet's exact composition and atmospheric conditions remain unknown, leaving much to the imagination and further investigation. The study of Proxima Centauri b offers a compelling case for comparative planetary habitability. By examining the diverse conditions found on exoplanets, scientists can refine their understanding of what makes a world habitable. Proxima Centauri b, with its unique characteristics and proximity, serves as a natural laboratory for exploring these questions. As our knowledge of exoplanets continues to grow, so too does our appreciation for the vast array of environments that could potentially support life. The journey to understand Proxima Centauri b is just beginning, and with each new discovery, we edge closer to unraveling the mysteries of our cosmic neighborhood. Proxima Centauri b versus Earth. Nestled in the Alpha Centauri star system, a mere 4.24 light-years from Earth, lies Proxima Centauri b, our nearest potentially habitable neighbor. This exoplanet orbits within the habitable zone of its red dwarf star, Proxima Centauri, where conditions might allow for liquid water to exist on its surface. The proximity of Proxima Centauri b to Earth makes it an enticing target for future exploration and study, offering a tantalizing glimpse into the possibilities of life beyond our solar system. In comparison to Earth, Proxima Centauri b presents a mix of intriguing similarities and stark differences. Both planets reside within the habitable zones of their respective stars, suggesting the potential for liquid water. However, Proxima Centauri b's orbit is much closer to its star than Earth is to the Sun, completing a full revolution in just 11.2 Earth days. This proximity subjects the planet to intense radiation and stellar winds, which could pose significant challenges to habitability. Despite these harsh conditions, the planet's potential to harbor liquid water keeps scientists hopeful. The discovery of Proxima Centauri b was a monumental achievement, announced in 2016 by the European Southern Observatory. Astronomers detected the planet using the radial velocity method, observing the subtle wobbles in Proxima Centauri's motion caused by the gravitational pull of the orbiting planet. This method, combined with extensive follow-up observations, confirmed the existence of Proxima Centauri b and provided initial insights into its characteristics. The discovery sparked a wave of excitement and curiosity as scientists and enthusiasts alike pondered the possibilities of this nearby world. One of the most compelling aspects of Proxima Centauri b is its potential to support life. While the planet's harsh environment presents significant challenges, the presence of liquid water could create conditions conducive to life as we know it. Scientists are particularly interested in studying the planet's atmosphere, which could provide crucial clues about its habitability. Future missions, such as the James Webb Space Telescope and advanced ground-based observatories, aim to probe the atmosphere of Proxima Centauri b, searching for biosignatures and other indicators of life. The quest to understand this nearby world is just beginning, and the discoveries made could reshape our understanding of life in the universe. Proxima Centauri b versus other exoplanets. In the vast cosmic sea, Proxima Centauri b stands out like a beacon, a tantalizing world that orbits the closest star to our solar system. This exoplanet, often dubbed our nearest potentially habitable neighbor, is a mere 4.24 light-years away, a stone's throw in astronomical terms. Its proximity alone makes it a prime target for study, but it's the potential for habitability that truly sets Proxima Centauri b apart from the myriad of other exoplanets scattered throughout the galaxy. Discovered in 2016 through the radial velocity method, Proxima Centauri b was found by detecting the tiny wobbles it induces in its host star, Proxima Centauri, as it orbits. This method relies on the gravitational influence of the planet on the star, causing slight shifts in the star's light that can be measured by sensitive instruments. The discovery was a monumental achievement, as it confirmed the existence of a planet in the habitable zone of the closest star to our own. This zone, often referred to as the Goldilocks zone, is the region around a star where conditions might be just right for liquid water to exist on the surface of a planet. Compared to other exoplanets, Proxima Centauri b's proximity offers unparalleled opportunities for detailed study and potential future exploration. While thousands of exoplanets have been discovered, many are too far away for us to observe directly or study in detail. Proxima Centauri b, on the other hand, is close enough that next-generation telescopes, like the James Webb Space Telescope, may be able to analyze its atmosphere for signs of habitability. This could include looking for biosignatures, such as oxygen, methane, or other gases that might indicate the presence of life. Moreover, Proxima Centauri b's potential habitability is a subject of intense scientific debate and excitement. It orbits within the habitable zone of its star, receiving about 65% of the stellar energy that Earth receives from the Sun. However, Proxima Centauri is a red dwarf star, much smaller and cooler than our Sun. This means that Proxima Centauri b is likely tidally locked, with one side permanently facing its star and the other in perpetual darkness. This could lead to extreme temperature differences and unique environmental conditions. Despite these challenges, the possibility of liquid water existing on its surface makes Proxima Centauri b a compelling candidate in the search for life beyond Earth. Technological challenges in observation. Nestled in the cosmic backyard of our solar system, Proxima Centauri b orbits the closest star to our Sun, a mere 4.24 light-years away. This exoplanet, often hailed as our nearest potentially habitable neighbor, has sparked immense interest and excitement. Its proximity and location within the habitable zone of its star make it a prime target for astronomers seeking signs of life beyond Earth. However, observing Proxima Centauri b presents a unique set of technological challenges that push the boundaries of current astronomical capabilities. The primary hurdle in observing Proxima Centauri b is its proximity to its parent star, Proxima Centauri. The planet's orbit is incredibly close, completing a full revolution in just 11.2 Earth days. This closeness means that the planet is often lost in the overwhelming glare of the star, making direct imaging nearly impossible with current technology. Astronomers have to rely on indirect methods, such as the radial velocity method or transit photometry, to infer the planet's presence and characteristics. These methods, while effective, provide limited data compared to direct imaging. Another significant challenge is the star's activity. Proxima Centauri is a red dwarf star, known for its intense stellar flares and magnetic activity. These flares can obscure the subtle signals that astronomers use to study the planet, making it difficult to gather accurate data. Additionally, the star's activity can potentially strip away the planet's atmosphere, posing questions about its habitability. To overcome these challenges, astronomers need advanced instruments and techniques that can filter out the star's noise and focus on the planet's signals. The technological hurdles don't end there. Proxima Centauri b's relatively small size and low mass make it a challenging target for study. Its gravitational influence on the star is minimal, making it difficult to detect using the radial velocity method. Furthermore, the planet's orbit is not edge-on from our perspective, reducing the chances of observing transits where the planet passes in front of the star from our viewpoint. This limitation hampers the use of transit photometry, another crucial tool in exoplanet observation. To overcome these obstacles, astronomers are developing next-generation instruments and missions, such as the James Webb Space Telescope and the upcoming extremely large telescopes, which promise to revolutionize our ability to study distant worlds like Proxima Centauri b. Current observation techniques. Nestled in the constellation of Centaurus, a mere 4.24 light-years from our blue marble, lies Proxima Centauri b, an exoplanet that has ignited the imagination of scientists and dreamers alike. This tantalizing world orbits within the habitable zone of Proxima Centauri, a red dwarf star that is the closest stellar neighbor to our solar system. The proximity of Proxima Centauri b makes it a prime target for current observation techniques, which are continually evolving to unravel the mysteries of this potentially habitable neighbor. The discovery of Proxima Centauri b was a triumph of modern astronomy, achieved through the meticulous application of the radial velocity method. This technique involves detecting the tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. By measuring these subtle shifts in the star's spectrum, astronomers can infer the presence and characteristics of exoplanets. In the case of Proxima Centauri b, these observations revealed a planet with a minimum mass of about 1.3 Earth masses, orbiting its star every 11.2 days. The proximity of Proxima Centauri allows for more detailed observations than would be possible for more distant stars, providing a unique opportunity to study a potentially habitable world in our cosmic backyard. Current observation techniques are not limited to the radial velocity method. Transit photometry, which measures the dimming of a star's light as a planet passes in front of it, has also been employed to study Proxima Centauri b. Although the planet's orbit does not currently favor transit events from our vantage point, future observations or changes in the planet's orbit could make transit photometry a valuable tool. Additionally, astronomers are using the Hubble Space Telescope and other advanced instruments to study the star's activity and the planet's potential atmosphere. These observations are crucial for understanding the planet's habitability, as the star's intense radiation and flares could pose significant challenges to any potential life. The proximity of Proxima Centauri b offers a unique advantage for future observation techniques, such as direct imaging and spectroscopy. These methods aim to capture actual images of the planet and analyze its atmospheric composition, providing direct evidence of its habitability. The upcoming James Webb Space Telescope, JWST, and other next-generation instruments will push the boundaries of our observational capabilities, potentially revealing the secrets of Proxima Centauri b's atmosphere and surface conditions. As our understanding of this nearby world deepens, so too does our appreciation for the incredible diversity and potential of the cosmos. Future observation missions. Nestled in the habitable zone of Proxima Centauri, a mere 4.24 light-years from Earth, Proxima Centauri b is our closest potentially habitable neighbor. This exoplanet, slightly larger than Earth, orbits within the temperate region of its star, where liquid water could potentially exist. The proximity of Proxima Centauri b makes it an enticing target for future observation missions, offering a unique opportunity to study a potentially habitable world outside our solar system. Several missions are already in the pipeline to get a closer look at this intriguing exoplanet. The European Space Agency's Aerial Atmospheric Remote Sensing Infrared Exoplanet Large Survey mission, set to launch in the late 2020s, will study the atmospheres of around 10 known exoplanets, including Proxima Centauri b. Aerial will focus on understanding the composition, formation, and evolution of these distant worlds. By analyzing the light that passes through the planet's atmosphere as it transits its star, Aerial could provide valuable insights into the atmospheric composition and potential habitability of Proxima Centauri b. NASA's upcoming Habitable Worlds Observatory, HWO, planned for the 2030s, will also turn its gaze towards Proxima Centauri b. This mission aims to directly image and characterize Earth-like planets around nearby stars. HWO will use advanced coronagraphs and star shades to block out the overwhelming light of the parent star, allowing it to capture direct images of the planet. This will enable scientists to study the planet's surface, atmosphere, and even potential biosignatures, providing a more comprehensive understanding of its habitability. In addition to these dedicated exoplanet missions, ground-based observatories are also gearing up to study Proxima Centauri b. The extremely large telescope, ELT, currently under construction in Chile, will be the world's largest optical and infrared telescope. With its immense light-gathering power and advanced adaptive optics, the ELT will be capable of directly imaging Proxima Centauri b and studying its atmosphere in unprecedented detail. This will allow astronomers to search for signs of water vapor, oxygen, and other potential indicators of habitability. The proximity of Proxima Centauri b makes it an ideal target for these advanced ground-based observatories, offering a chance to explore a potentially habitable world in our cosmic backyard. The role of the James Webb Space Telescope. Nestled in the constellation of Centaurus, a mere 4.24 light-years from our solar system, lies Proxima Centauri b, an exoplanet that has captured the imagination of astronomers and space enthusiasts alike. This distant world orbits within the habitable zone of its parent star, Proxima Centauri, a red dwarf that is the closest star to our Sun. The proximity of Proxima Centauri b makes it an enticing target for scientists seeking to understand the potential for life beyond Earth. Its location within the habitable zone suggests that liquid water could exist on its surface, a crucial ingredient for life as we know it. However, the planet's potential habitability is still a subject of debate, as its close orbit around a red dwarf star exposes it to intense radiation and stellar flares. The discovery of Proxima Centauri b was announced in 2016, the result of years of painstaking observation and analysis. Astronomers used the radial velocity method, detecting the tiny wobbles in Proxima Centauri's motion caused by the gravitational pull of the orbiting planet. This method, combined with extensive follow-up observations, confirmed the existence of Proxima Centauri b and provided initial estimates of its mass and orbital period. The planet is believed to be at least 1.3 times the mass of Earth, placing it in the category of super-Earths. Its orbit is remarkably close to its star, completing a full revolution in just 11.2 Earth days. Despite this proximity, the red dwarf's dimness allows for temperatures that could permit liquid water to exist on the planet's surface. Enter the James Webb Space Telescope, JWST, the most powerful space telescope ever built, designed to peer into the depths of the universe with unprecedented clarity. Launched in 2021, JWST is equipped with advanced instruments capable of analyzing the atmospheres of exoplanets, including Proxima Centauri b. By observing the light that filters through a planet's atmosphere as it passes in front of its star, JWST can identify the chemical signatures of various gases. This technique, known as transit spectroscopy, could reveal the presence of water vapor, methane, carbon dioxide, and other molecules that might indicate habitability or even biological activity. The telescope's infrared capabilities are particularly well suited for studying red dwarf stars and their planets, as these stars emit most of their light in the infrared spectrum. One of the most exciting aspects of JWST's mission is its potential to detect biosignatures, the chemical signs of life. For instance, the presence of oxygen, methane, and other specific molecules in combination could suggest biological processes at work. However, interpreting these data is complex, as non-biological processes can also produce similar signatures. Scientists must carefully analyze the context and consider multiple lines of evidence before drawing conclusions. Proxima Centauri b presents a unique challenge due to its proximity to its star and the potential for intense stellar activity to strip away its atmosphere. Nevertheless, JWST's advanced instruments offer the best chance yet to unravel the mysteries of this enigmatic world. The telescope's observations could provide crucial insights into the planet's atmospheric composition, surface conditions, and potential for habitability, bringing us one step closer to answering the age-old question, are we alone in the universe? Theoretical models of Proxima Centauri b. Nestled in the constellation of Centaurus, a mere 4.24 light-years from our solar system, Proxima Centauri b orbits its red dwarf star, Proxima Centauri. This exoplanet, our closest potentially habitable neighbor, has sparked immense interest and speculation. Theoretical models of Proxima Centauri b aim to understand its conditions, potential for habitability, and the possibilities of life. These models are crucial in guiding future observations and missions. Proxima Centauri b was discovered using the radial velocity method, which detects the wobble of a star caused by an orbiting planet. This method hinted at a planet with a minimum mass similar to Earth, orbiting within the habitable zone of its star. Theoretical models build upon this data, incorporating factors like stellar radiation, planetary composition, and atmospheric properties. For instance, models consider the intense stellar winds and 10th-ray flares from Proxima Centauri, which could strip away a planet's atmosphere. Some models suggest that Proxima Centauri b might have a tidally locked rotation, with one side perpetually facing the star and the other in eternal night. The potential habitability of Proxima Centauri b hinges on several factors. Its proximity to the star means it receives about 65% of the solar radiation Earth gets, but the red dwarf's different spectral composition changes the dynamics. Models explore the possibility of a global ocean, with liquid water existing beneath a frozen surface, similar to Europa or Enceladus. Others consider the potential for a thick atmosphere that could regulate temperature and protect against radiation. The planet's eccentric orbit also plays a role, with variations in distance from the star affecting surface temperatures and climate stability. Despite the challenges, the allure of Proxima Centauri b remains strong. Its proximity makes it a prime target for future observation and potential exploration. The James Webb Space Telescope and upcoming missions like the Breakthrough Starshot initiative aim to gather more data, testing, and refining these theoretical models. Understanding Proxima Centauri b not only expands our knowledge of exoplanets, but also brings us one step closer to answering the age-old question: are we alone in the universe? Potential for life, microbial. Nestled in the habitable zone of Proxima Centauri, a mere 4.24 light-years from our solar system, lies Proxima Centauri b. This exoplanet, often hailed as our nearest potentially habitable neighbor, orbits a red dwarf star, the closest star to the Sun. Its proximity and location within the habitable zone, where liquid water could theoretically exist, make it a tantalizing target for astronomers and astrobiologists alike. The discovery of Proxima Centauri b was announced in 2016, detected through the radial velocity method, which measures the gravitational tug of an exoplanet on its host star. This method revealed a planet with a minimum mass of about 1.3 Earth masses, suggesting it could be a rocky world like our own. The potential for microbial life on Proxima Centauri b hinges on several factors, primarily the presence of liquid water. Despite its star being much cooler and dimmer than our Sun, Proxima Centauri b's close orbit, about 7.5 million kilometers, positions it within the habitable zone. However, the planet is likely tidally locked, meaning one side perpetually faces the star while the other remains in eternal darkness. This could create extreme temperature gradients, with a temperate twilight zone where liquid water might exist. Microbial life, as we know it, requires water, a source of energy, and certain chemical building blocks. If these conditions are met, even in a narrow habitable band, life could potentially thrive. One of the most compelling arguments for microbial life on Proxima Centauri b is the resilience of extremophiles on Earth. These hardy microorganisms inhabit some of the most inhospitable environments, from the scorching hot springs of Yellowstone to the frigid depths of the Antarctic ice. If life can persist in such extreme conditions on Earth, it's not unreasonable to speculate that similar life forms could exist on Proxima Centauri b. The planet's potential atmosphere, though not yet detected, could provide the necessary protection and chemical environment for microbial life. Future missions, such as the James Webb Space Telescope, aim to analyze the planet's atmosphere for biosignatures, which could provide concrete evidence of life. However, the prospects for life on Proxima Centauri b are not without challenges. The planet is subjected to intense stellar radiation and frequent solar flares from its host star, which could strip away its atmosphere and bombard the surface with harmful radiation. Additionally, the planet's proximity to its star means it is likely tidally locked, leading to extreme environmental conditions. Despite these hurdles, the potential for microbial life remains a captivating possibility. The study of Proxima Centauri b not only advances our understanding of exoplanets, but also fuels our imagination about the potential for life beyond our solar system. As we continue to explore and learn, Proxima Centauri b stands as a beacon of hope in our quest to find life among the stars. Potential for life, complex. Nestled in the habitable zone of Proxima Centauri, a red dwarf star just 4.24 light-years from our Sun, lies Proxima Centauri b. This exoplanet, often hailed as our nearest potentially habitable neighbor, has sparked considerable excitement and speculation within the scientific community and beyond. Its proximity to Earth makes it a prime target for future exploration and study, offering a tantalizing opportunity to investigate the possibility of life beyond our solar system. The planet's location within the habitable zone, where conditions could allow for liquid water to exist on its surface, further fuels the intrigue surrounding this distant world. Discovered in 2016 through the radial velocity method, Proxima Centauri b was identified by observing the subtle wobbles in its host star's motion caused by the planet's gravitational pull. This method, which measures the Doppler shift in the star's light, has been instrumental in detecting numerous exoplanets. The discovery team, led by Guillaume Anglada-Escude, noted that the planet's minimum mass is approximately 1.3 times that of Earth, suggesting it could be a rocky world. However, the exact nature of its atmosphere, surface conditions, and potential for habitability remain subjects of ongoing research and debate. The potential for life on Proxima Centauri b is complex and multifaceted. While its location within the habitable zone is promising, several factors complicate the assessment of its habitability. For instance, Proxima Centauri is a flare star, meaning it periodically releases intense bursts of radiation that could strip away a planet's atmosphere and expose its surface to harmful levels of ultraviolet and 10th-ray radiation. Additionally, the planet's proximity to its star, completing an orbit in just 11.2 Earth days, means it is likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. This could result in extreme temperature gradients and atmospheric dynamics that might not be conducive to life as we know it. Despite these challenges, the scientific community remains optimistic about the potential for Proxima Centauri b to harbor life. Recent studies have explored the possibility of a dynamic atmosphere that could redistribute heat and protect the planet from stellar flares. Moreover, the discovery of complex organic molecules in the interstellar medium suggests that the building blocks of life might be widespread throughout the universe. As our understanding of exoplanets and their environments continues to evolve, Proxima Centauri b stands as a beacon of hope and a testament to the enduring human quest to explore the unknown. Future missions, such as the James Webb Space Telescope and advanced ground-based observatories, will provide deeper insights into this enigmatic world, bringing us closer to answering one of humanity's most profound questions: are we alone in the universe? Challenges to life, radiation, and flare activity. Nestled in the Alpha Centauri star system, a mere 4.24 light-years from Earth, Proxima Centauri b orbits within the habitable zone of its red dwarf star. This exoplanet, often hailed as our nearest potentially habitable neighbor, has sparked immense interest in the scientific community. Discovered through the radial velocity method, which detects the wobble of a star caused by an orbiting planet, Proxima Centauri b is roughly 1.3 times the mass of Earth. Its proximity to our solar system makes it a prime target for future exploration and study. However, the journey to understanding its habitability is fraught with challenges, not least of which are the intense radiation and flare activity from its host star. Proxima Centauri, the star around which this exoplanet orbits, is a red dwarf. These stars are known for their violent and frequent flare activity. Flares are sudden, intense bursts of radiation that can significantly impact any nearby planets. Proxima Centauri b orbits its star at a distance of about 7.5 million kilometers, much closer than Earth's orbit around the Sun. This proximity means the planet is subject to extreme radiation levels. The star's flares can bathe Proxima Centauri b in high-energy particles and 10th rays, posing a substantial challenge to the potential development and sustainability of life. The radiation could strip away the planet's atmosphere, if it has one, and expose any surface life to harmful levels of ultraviolet and 10th ray radiation. Despite these challenges, the scientific community remains optimistic. Red dwarfs like Proxima Centauri are the most common type of star in the Milky Way, and many of them host planets within their habitable zones. The study of Proxima Centauri b offers valuable insights into the potential habitability of planets around these stars. Researchers are exploring various scenarios, including the possibility of a magnetic field or a thick atmosphere that could shield the planet from the worst of the radiation. Additionally, the study of extremophiles on Earth, organisms that thrive in extreme environments, provides hope that life might find a way to survive even under such harsh conditions. The quest to understand Proxima Centauri b is not just about finding another Earth. It's about expanding our knowledge of where life can exist in the universe. Challenges to life: atmospheric retention. Nestled in the habitable zone of Proxima Centauri, a mere 4.24 light-years from our solar system, Proxima Centauri b is the closest exoplanet with the potential to harbor life. This tantalizing world orbits a red dwarf star, a type known for its stellar flares and intense radiation. The planet's proximity to Earth makes it a prime target for study, offering a unique opportunity to explore the possibilities of life beyond our solar system. However, the road to understanding its habitability is fraught with challenges, not least of which is the question of atmospheric retention. Atmospheres are crucial for life as we know it. They regulate temperature, protect against harmful radiation, and provide the necessary gases for respiration. For Proxima Centauri b, the retention of such an atmosphere is a significant hurdle. The planet's close orbit around its star subjects it to extreme tidal forces and intense stellar winds. These forces can strip away atmospheric gases, leaving the planet barren and inhospitable. The process is not well understood, but models suggest that planets around red dwarfs may struggle to maintain their atmospheres over time. One of the key factors in atmospheric retention is the planet's magnetic field. Earth's magnetic field, for instance, acts as a shield against solar wind, deflecting charged particles and preserving our atmosphere. Proxima Centauri b's magnetic field strength is uncertain, but if it is weak or non-existent, the planet could be vulnerable to atmospheric loss. Additionally, the planet's proximity to its star means it is likely tidally locked, with one side perpetually facing the star. This could lead to extreme temperature differences and atmospheric circulation patterns that further complicate the retention of gases. Another challenge is the composition of the atmosphere itself. Even if Proxima Centauri b can retain an atmosphere, its composition might not be conducive to life. The planet's formation history and the type of star it orbits can influence the gases present. For example, the intense radiation from Proxima Centauri could break down molecules like water and carbon dioxide, leading to a different atmospheric makeup than Earth's. Understanding these processes requires detailed observations and sophisticated modeling, which are ongoing. Despite these challenges, the study of Proxima Centauri b offers invaluable insights into the potential for life in the universe and the conditions that make a planet habitable. Human exploration. Current feasibility. Nestled in the Alpha Centauri star system, a mere 4.24 light-years from Earth, Proxima Centauri b orbits within the habitable zone of its red dwarf star. This exoplanet, slightly larger than Earth, has sparked immense interest due to its proximity and potential to harbor life. Discovered in 2016 through the radial velocity method, scientists detected the subtle wobbles in Proxima Centauri's motion caused by the planet's gravitational pull. This method, along with subsequent observations, revealed that Proxima Centauri b completes an orbit every 11.2 Earth days, placing it in the Goldilocks zone where liquid water could exist. Human exploration of Proxima Centauri b, however, remains a daunting challenge. Current spacecraft technology, even at its most advanced, would take tens of thousands of years to reach the planet. The Voyager 1 spacecraft, launched in 1977 and currently the farthest human-made object from Earth, is traveling at about 38.0 mph. At this speed, it would take over 70 years to reach Proxima Centauri b. Clearly, a more innovative approach is needed. Breakthrough Starshot, an ambitious project, aims to develop tiny, lightweight probes propelled by powerful lasers. These probes could theoretically reach the Alpha Centauri system within a few decades. Yet, even this cutting-edge technology faces significant hurdles, including the development of sufficiently powerful lasers and the miniaturization of necessary scientific instruments. The feasibility of human exploration is further complicated by the harsh space environment. Cosmic radiation, microgravity, and the psychological toll of long-duration space travel pose substantial risks. Proxima Centauri b itself may not be the paradise we hope for. Its close proximity to its star means it is likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. Additionally, stellar flares from the red dwarf could strip away any potential atmosphere, making the planet inhospitable. Despite these challenges, the allure of Proxima Centauri b as a potential second home for humanity drives ongoing research and technological innovation. The journey to our nearest potentially habitable neighbor is fraught with obstacles, but the rewards of success could be immeasurable. Human exploration, future possibilities. Nestled in the constellation of Centaurus, a mere 4.24 light-years from our blue marble, lies Proxima Centauri b, an exoplanet that has captured the imagination of scientists and dreamers alike. This distant world orbits within the habitable zone of its red dwarf star, Proxima Centauri, a region where conditions might allow for liquid water to exist. The proximity of Proxima Centauri b makes it a tantalizing target for future exploration, offering a unique opportunity to study a potentially habitable world beyond our solar system. Discovered in 2016 through the radial velocity method, which detects the wobble of a star caused by an orbiting planet, Proxima Centauri b has since been the subject of intense scrutiny and speculation. The journey to Proxima Centauri b is no small feat at current technological capabilities. A spacecraft would take tens of thousands of years to reach this distant neighbor. However, innovative projects like Breakthrough Starshot aimed to revolutionize interstellar travel. This initiative proposes using powerful lasers to propel tiny, lightweight probes to a significant fraction of the speed of light. If successful, these probes could reach Proxima Centauri b within a few decades, providing valuable data about the planet's atmosphere, surface conditions, and potential for habitability. The data collected could reshape our understanding of planetary systems and the potential for life beyond Earth. One of the most exciting aspects of exploring Proxima Centauri b is the possibility of finding signs of life. The planet's location within the habitable zone suggests that liquid water could exist on its surface, a crucial ingredient for life as we know it. However, the red dwarf star it orbits is known for intense stellar flares, which could strip away the planet's atmosphere and expose it to harmful radiation. Scientists are eager to determine whether Proxima Centauri b has a magnetic field or other protective mechanisms that could mitigate these effects. Understanding these factors will be key to assessing the planet's potential for hosting life. Future missions to Proxima Centauri b will not only advance our scientific knowledge, but also inspire humanity to push the boundaries of exploration. The challenges of interstellar travel require innovative solutions, from advanced propulsion systems to compact, resilient spacecraft. As we develop the technology to reach this nearby exoplanet, we are also investing in a future where humanity becomes a multi-planetary species. The journey to Proxima Centauri b is more than just a scientific endeavor. It is a testament to human curiosity and our relentless pursuit of the unknown. The significance of Proxima Centauri b for astronomy. Nestled in the constellation of Centaurus, a mere 4.24 light-years from our solar system, lies Proxima Centauri b, an exoplanet that has captured the imagination of astronomers and space enthusiasts alike. Its proximity to Earth makes it an enticing target for study, offering a unique opportunity to explore a potentially habitable world beyond our solar system. Proxima Centauri b orbits within the habitable zone of its star, Proxima Centauri, a red dwarf that is the closest star to our Sun. This positioning suggests that the planet could have conditions suitable for liquid water to exist on its surface, a crucial ingredient for life as we know it. The discovery of Proxima Centauri b was announced in 2016, the result of an intensive observational campaign using the radial velocity method. This technique involves detecting the subtle wobbles in a star's motion caused by the gravitational pull of an orbiting planet. Astronomers noticed periodic shifts in the light from Proxima Centauri, revealing the presence of a planet with a minimum mass similar to Earth. The planet's orbit is remarkably close to its star, completing a full revolution in just 11.2 Earth days. Despite this proximity, the relatively cool nature of Proxima Centauri places Proxima Centauri b within the habitable zone, where temperatures could allow for liquid water. Proxima Centauri b's significance for astronomy is multifaceted. Its closeness provides an unparalleled opportunity for detailed study, allowing scientists to gather more data than would be possible for more distant exoplanets. This proximity enables the use of advanced observational techniques, such as the transit method and direct imaging, to probe the planet's atmosphere and surface conditions. Understanding Proxima Centauri b could offer insights into the formation and evolution of planetary systems around red dwarf stars, which are the most common type of star in our galaxy. Moreover, the study of this exoplanet could inform our search for life beyond Earth, as it represents a nearby laboratory for testing theories about habitability and the potential for extraterrestrial life. The potential habitability of Proxima Centauri b has sparked intense debate and speculation. While its location within the habitable zone is promising, several challenges must be considered. Proxima Centauri is known to be an active star, emitting powerful flares that could strip away a planet's atmosphere and expose its surface to harmful radiation. Additionally, the planet's tidally locked orbit, where one side perpetually faces the star, could result in extreme temperature differences and harsh conditions. Despite these challenges, the study of Proxima Centauri b continues to push the boundaries of our understanding of planetary habitability and the potential for life in the universe. Its proximity and potential make it a beacon for astronomers, guiding our exploration of the cosmos and our search for answers to some of the most profound questions about our place in the universe. As we wrap up our journey to Proxima Centauri b, let's recap the key points that make this exoplanet so thrilling. Just 4.24 light-years away, it's our closest potentially habitable neighbor, orbiting within the habitable zone of its red dwarf star, Proxima Centauri. Discovered in 2016 through the radial velocity method, this Earth-sized world has sparked our imagination and scientific curiosity. With the right conditions, it could potentially host liquid water, a crucial ingredient for life as we know it. Imagine standing on the surface of Proxima Centauri b, gazing up at a sky where Proxima Centauri looms large, and our own Sun is just a faint star among many. The possibilities are as vast as the cosmos itself. But remember, while the potential for habitability is exciting, we still have much to learn about this distant world. So what's next? The future of space exploration is bright, and Proxima Centauri b is sure to play a significant role. With upcoming missions and advancements in technology, we're inching closer to uncovering the mysteries of this enigmatic exoplanet. Stay tuned for more updates and discoveries as we continue to explore the wonders of our universe. In the meantime, join the conversation. Share your thoughts, theories, and dreams about Proxima Centauri b. What do you hope we'll find there? Let's keep the excitement alive and the curiosity burning bright. Together, we're not just spectators of the cosmos, we're active participants in its ongoing story. See you in the stars.